Hey, thank you. I'm here to talk about Intake, which is funded by Anaconda, but is fully open source and open to all. Most of you will not have used it before. It's new, and I'm here to encourage you to try it and make your feedback known. Requests, conversation, all welcome. And yeah, get involved. So to start off, I expect there are quite a few data scientists here, but even if you aren't, you've probably come across code that looks like this. You've probably written code that looks like this. For those that don't know, all that this code cell is doing is loading, can you see my pointer? Yes, okay. 3 particular CSV files, and it's using pandas to stitch them into a single data frame. And the point of the code cell is that you want to create this data frame so that then you can go off and do your analysis on that, and the job that you're doing is that analysis. So everything that's in this code, this cell is necessary but not very interesting. Now, I'm going to take you through a few opinions that different people might have about a code cell that looks like this, but first I just want to ask you, who has written something that looks like this in the past? And that is nearly everybody. I'd say a good 80% of people put their hands up, and the rest of you are maybe a little bit shy. So first opinion, this person I'm calling the data user, that is the one that is actually going to execute this and wants to do something with the data frame that it produces. By the way, I'm using data frame and CSVs as very common. There's lots of other types of data that you might be wanting to load, and lots of, well, another set of different outputs that you might consider, like arrays and things. I'll just keep to the simple case for now. So the data user had to write this, probably, and they don't want to ever have to do this. All they want is to have the data frame and do things with the data frame. That is their job. Secondly, there is nothing in this code cell that actually tells you what this data is. You have some file names, you have some URL, you have some other stuff that is necessary, but you don't know if this is the right thing. If you're coming back to this code in the future, you don't really know what this was for. Sure, you can comment, you can keep extra information around, but it's not inherent in what you're doing. So that's a real problem, figuring out which data set you need to do the particular task that you want to do. Second person is the one that has actually put these files into place. They realize that somebody is using files that are not actually the current best data that they should be using. There's been a new update, and they need to let the user know that this has happened somehow. Secondly, maybe it's not CSV anymore. Maybe it's not stored at this HTTP endpoint anymore. Lots of things can have changed, and maybe very good reasons for why those things have changed. In every case, the person who's managing how the data gets into the system needs to have a way to tell the user that this has happened, so an alert, and needs to have a way of getting the user to be able to get at this data, which is now in a different format, in a different storage location. That's all painful stuff. Thirdly, if you have an IT department at your organization, they would be very angry about you including your credentials directly in your code. You should never do that. This is a notebook. You can mess around with notebooks, treat them as sandbox. No, shouldn't do that. You should certainly never check it into your version control. So there's that part. And then actually the most common problem with code like this is that it tends to be copied and pasted from one person to the other. Hey, where's that thing that gets me the data that I need to do my job? Oh, here it is, copy and paste that, it will work. This is very antithesis to what IT security and monitoring is about. And then finally, dev, which is what I count myself as. What if now the new data format, because let's say your data production engine switched from some logging thing to Kafka, say now it's coming in Avro. Pandas doesn't read Avro, so what do? Somebody's going to have to write some code Even more so if it's actually on a different storage system, somebody needs to go and stitch all these different things together, and that's a pain. Then they have to get this code again to the user. The user is probably not the one that's writing that code. They may be, maybe not. There's quite a tangle of things going on here. And all of this is what intake is aimed at solving. So in the intake world, that code cell looks something like this. As an example, you have some file, in this case, which encodes a catalog definition. In there, it tells you what your data sets are and how to read them, so that the user, all they do is reference a catalog, and then they do .read, and there's your data frame. So all of the stuff that you had before is now abstracted away. It's hidden in a definition, and the user just does this one-liner to get their data out. I will show you what these things look like in a moment, but I'll first note to say the YAML definition is only one possible way that you can encode data set prescriptions. So now I'll go into a little bit more detail about these points of view and why intake exists and how it's supposed to solve these problems. So here is a data scientist, or at least this is what Google image search tells me a data scientist looks like. Those of you that are data scientists, I'm sure you draw graphs and things all the time and whatever geometry stuff is going on here. Their main concern is, what are my data sets? Of those, which one has the characteristics that meet the job that I now need to do? And then how do I actually go about getting hold of that so that I can get on with my job? The data user's job is to take that data and do something with it. Their job is not to figure all that stuff out. So you already saw this is the same cell again. In the intake world, it becomes a one-liner, which is good. You also get some additional functionality. For example, this GUI, which I will demonstrate to you in a live demo, which hopefully runs. It's not much live code has been at this conference, so you'll actually get to see some. Within your catalogs, you should be able to search. You should be able to, for each of your data entries, get information about what it is, what data shape it has, various things like that. We have built-in plotting so that you can get quick plots that you design, or there may be some predefined quick plots that demonstrate what the data is about, and of course the one-line loading. From the provider's point of view, they care about making data available, getting it to the users. They need to know what data they have internally, and they need to be able to describe their internal data sources anyway. So they're already doing some of this somehow, and many companies have solved this or partially solved this problem many times over. So here's an opportunity for doing it in a structured way that we can all take part in, standardize. And most importantly, the data provider needs to be able to get the user to be able to do what the user does, and we're going to encode things using intake and pass that to the user. And that's done like this. So here is an actual YAML prescription of a data set. This is just purely for example, and it's something that looks pretty simple. This is actually a fairly complicated version of one. You have some sources. We have one that is called first data entry. It's going to be read by a thing called CSV. It has some description. It has some user parameters. Those are things that we can actually allow the user to choose between, in this case, whether they want part 1 or part 2. Arbitrary metadata, where you can encode all of the important information about your data, goes in there. And actual arguments that are going to be passed to a Python function. That Python function, in this case, is just going to read CSV, and we probably already know how to do that. And that's it. So this gets written into a file. That file is shared with the user. It can be literally given to the user, but probably you want to put it into some centralized place on S3 or whatever, and then you can change the catalog. The user doesn't know. The user just loads the latest data every time. They don't need to know how this process works. IT, again, they care about security, about granting access, about monitoring who's touching what, about authenticating how those people actually get into the system. And critically, this last one is important for many organizations. They actually want to be the gatekeepers of data that's coming into the system. So in the intake world, they can have opinions about how credentials are passed around. Here is another YAML catalog. In this case, the data is stored on S3, for example, and you're going to provide username and password to be able to access it. And this particular prescription, you don't need to care too much about how these details actually work for the time being, but you have a user parameter here, which is going to fill in the username automatically using environment variables or other mechanisms. There are other possibilities, but it's still going to require the username to pass their password at runtime. That's one possibility. There are lots of possibilities. So these hooks exist for IT to be able to ensure that things are getting from the environment or from the user into the system without having to hard code them into scripts. Also, there is an intake server. So you can host these catalogs not as files, but as an endpoint that the user can touch. And then you can control how authentication happens with HTTP headers or Java web tokens or whatever is the right thing for you. You can also run your server as a data streaming service, so not just the data definitions, but the data itself. You can gatekeep there, and that means you have all the opportunities for authentication and monitoring that you might want to do. So that's all convenient. I expect we have probably fewer people who are at this end of things, but you can ask me about how this stuff works afterwards. And then finally, the developer. This doesn't look too much like me, but again, Google tells me that this is what a programmer looks like. You can see has been very short-sighted, quite hunched. Okay, fine. Hold on. I'll do that too. So the developer doesn't want to rewrite stuff that already exists out there. They want to use code that is good at loading data into memory, but they want a framework to put this within. They don't want to have to rewrite all the hooks to, oh, how do I connect to this data store? All these things should be in a consistent framework, and the API that is presented to the user should always be the same. You don't want to have to teach your user each time you write a piece of code, how do I go about using that particular piece of code? That's really annoying. And finally, you could submit your latest loading function to pandas or NumPy or whatever is appropriate for that particular type of data, but actually that's a pretty slow process. So intake provides a mechanism to get loading code out into the wild pretty easily. And this is what some intake code might actually look like. This is a real data driver from a tutorial, so it's not particularly complicated. But in this case, it connects to GitHub, and it views a set of issues on a particular repo in GitHub as a data set. And this goes to show that I'm not just talking about files now, I'm talking about data services that can provide things that you can think of as a data set. It's pretty short, you don't have to write many methods, and when you do this, then you get all the cataloging features of intake and actually quite a few features along the way as well. So those are built into intake. Intake itself is pretty easy to extend. It has lots of points with plugin architecture, so you can add to it as a developer. So those that are interested in intake as a project rather than just as a thing to use, then I want to see you on GitHub contributing tomorrow, maybe. I'm going to switch now to some live code. How am I doing? Yeah, okay. So I have two notebooks that I will fairly quickly go through. I want to leave plenty of time at the end for questions and discussions, so I'll make this pretty quick. One of the things that was on a slide but I didn't explicitly mention yet is that intake gives you the opportunity to install data using Conda. So this line I have run already, and when you've done that, then you have this built-in catalog that includes now some entries. This is a rate of various types of crime within the US over a time period. So having done conda install my data, I can now access the data. So it's there. I have an entry in this built-in catalog called US Crime. I can get information about it. It has some basic description. This is the same API as a user would go through for whatever kind of catalog they're connecting to. I can get more information about this. So Discover is now actually reading some part of the data, and I have a set of D types. Again, this is Panda's data frame, as it happens. Data frames are very common, but not the only option. You'll also notice that down here, this has a thing called plots. So in this particular case, just for example's sake, there is an automatic plotting spec built into the actual data description. So this is a hint to the user that this particular plot name is a useful thing to look at if you're interested in using this data. It just shows these are two columns in the original data. And apparently 1981 was a bad time if you had valuables in your house for some reason. Those of you that are history students maybe know what was going on there. I don't. And then there's the one-liner, which is, again, now you just do read, and now it's a data frame, and you can do usual data frame-like things to it, which I won't bother showing you. But I will show you the GUI. So this is the first GUI and the simplest GUI. Probably we will have some more standalone things also in the future. This shows the same built-in data set that you saw above with its details here on the right. And I can, again, access it using Discover. But I can also load more catalogs using this GUI. You can, of course, do this in code as well. So let me find my examples, and I'll just load one of them for you. This, by the way, is using Jupyter widgets, which I found really nice to get going with and to produce something simple enough to use here. So let's load a catalog. So I've done that, and the catalog appears here. And it has some entries in it. Again, I can page through these, and I can get information about them. One interesting thing about this particular test catalog is that it includes a reference to another catalog. So these things can be hierarchical, and you can build that. So the catalog is itself a data source. You can have catalogs that include other catalogs. So you can have master catalog that, yeah, you can see how that can be a very useful thing. Also, you can include remote. So we'll find out now if the Wi-Fi is still working. Yeah. So here we have, this is the data catalog that's currently used in production by the Pangeo collaboration. These are various scientific data sets. Meteorological ensemble of stuff, I gather. This is not my speciality, but people are using this now. And the point of it is that you can seamlessly point to online resources, whether it's HTTP or S3 or Google or Azure or whatever. All of these things work. And frequently, if you're doing that, then the data itself will also be stored in those cloud locations so that you can seamlessly get your user access to data that exists out there, and they don't need to worry about plumbing through the various connectors to be able to make that happen. Okay, swapping across to my second demo. If you're a data engineer, that is, you are interested in making catalogs, then this is how you would go about doing that. So I'm now going to talk about the dev part of actually writing drivers for intake or talking about enhancing intake itself. I'll just talk about the two kinds of intake users that I mentioned earlier. Intake comes with some built-in drivers for various data types. There's also a whole slew of other add-ons that you can install. I'll show you those in a moment. If you wanted to investigate how do I go about making a catalog for something, you might start like this. So for each of these drivers, there is an intake.open function, and you can read the docstrings of that function and figure out how it works. In this case, this is yet another CSV, and All I need to do to read this CSV is to pass it a URL. It could be something that's more complicated. Obviously, CSVs can have a number of problems. Other data formats may have lots of options that you would care about. This is the simplest case. So I've defined it, and I can do discover, and I can see that this passes fine. It has 3 columns, and I can actually read the data. So this source thing behaves exactly like one of the entries within a catalog, except that it's not in a catalog. I'm just using it for discovery's sake. I can also plot it. So this is just showing you a plot. You could play around with this a lot to figure out what set of keyword arguments here really demonstrates the features of your data set. hvplot is very nice for those that haven't come across it. This is HoloViews, bokeh, all of these things plug together very nicely, and it's a built-in feature of Intake to be able to do this. Okay, so the point of all of this is that we have this data source, and we can generate YAML automatically that describes what we just did above. All it really contains is a driver, so it's a CSV, and an argument. If we had more arguments, then they would all appear here, and this is a nice stub that you can put within one of your YAML catalogs. Here is a slightly more fleshed out version of the same thing as above. It now has a description. Now it includes the same plot as I had. So this now I put into a YAML file. I open that YAML file, and I can plot it again. I just called the plot basic up here. The point of doing it is to show you that the YAML file now does exactly the same thing as I had just discovered before. So I'm going to look at my data, figure out how to load it, encode it in the YAML file. This is now ready to pass off to a user. You might do that by posting it in GitHub, for example, or Gist, or anywhere that you have access to, which can include S3 or whatever you like. So if you post it there, now you can load it from remote, and again, you can do exactly the same thing. So now we have the data, except that it's coming from somewhere else. This is, in practice, the thing that you can pass to your user, and it's the easiest way to get them loading your data. So if you're starting off with Intake and you want to make catalogs, this is probably how you would go about it, at least to start off with. Later, you can get into making conda packages and all that kind of stuff. And then the final interesting thing, as I mentioned before, the catalog itself is also a data entry. It looks like this, and you can include this within other catalogs if you want to. Okay, so that's it for demonstration. I'm going to leave a good 10 odd minutes for discussion at the end. But I did promise you that I would show you the state of the drivers that currently exist. This is actually a set of repos. Each of these repos contains at least one driver. Some of them contain more. This is the website for general documentation about Intake, and this directory is on there. This is already out of date, so we have people that are contributing to this list currently, and I encourage you to consider the kind of data that you're interested in. If it's not on the list, do make that bit of code that is going to intakeify your existing data loading practices. You'll notice that quite a number of these are not files, but are data services of some kind, which is interesting. So Intake is really about unifying not just data loading, but data services. Some of them can actually be data catalogs themselves. So Intake, which is a fairly simple, easy to understand code base, can be the unifying umbrella that brings these things together. Again, now this is my summary slide, so I'll just take you through point by point. Intake provides consistent, simple API for users. It provides a cataloging system. You can use the YAML syntax. It's very simple. You can get going, but there are other ways to do that too. You separate out the people that prescribe what the data is, where it lives, how to load it, from the user who just now gets to load their data without worrying about anything else. You can access remote data, both for the catalogs and for the data itself, or remote data services. There is a plugin system. You can produce these things very easily, both the loaders and various other parts of the Intake system. There is the server for those that really want to lock up their infrastructure. And again, we can talk about that separately. And importantly for this crowd, it plugs in to various other elements of the PyData ecosystem. The GUI was running in Jupyter. Obviously, hvplot was being used to display those automatic quick plots. You can Conda install stuff. All of this exists on Conda. I work for Anaconda, so I have to say that. Most of the data types also interact very nicely with Dask because I also work on Dask, so I care about that. It means that for bigger than memory data sets, you can load using Dask if you want to. It's optional, you don't have to use Dask, but it does work well. And then finally, again, a call to everybody that's here, please try Intake and let me know what you think. The installation is this line here. You can come to GitHub and raise issues or provide pull requests, please. Very welcome. Documentation and general chatter on Gitter. So that leaves plenty of time, and you can shout out questions or come to the microphones, and we can start talking.
Can you do a compare and contrast with Apache Atlas?
I don't actually know how Atlas works. There are lots of pieces of software out there that do some of what Intake does. And I used to have a comparison slide in this talk to show what I viewed as their main focus. Atlas was not on that slide, but lots of other things were. And so, maybe you can tell me a little bit about how Atlas works, because I simply don't know that. But Intake is meant to be simple enough for everybody to get engaged. It really is a PyData focused thing. The question was, in a case where you have data coming in on a regular timetable and you want to be able to access both the most recent as a thing and separately the set of historical data sets. There isn't a built-in mechanism to do that, but you could encode it very easily. There is the concept of user parameters, for example. So the default could be latest, but the allowed set of things that you could choose could be all of the currently existing months. That would be a pretty simple way to do that.
Do I have to download my data every time?
I have a feeling I know why you asked that. The question, okay, so do I have to download my data every time? As I said, Intake comes with a number of freebies that make working with data a little bit easier. One particular contribution by somebody whose name I can't quite remember was a cache on first access mechanism. So you can choose to have this as part of your data definition. The first time a user actually wants to read your CSVs or whatever file type it may be, Intake will download it and keep a local copy of it so that all subsequent reads will happen much faster. Obviously, some data types lend themselves to this being useful and other data types not necessarily. And it's going to depend on whether you expect your user to be working from their workstation or whether this is something that's in the cloud, but it's a very nice option to have available to you. And this is a decision that's made by the catalog author on whether this particular data set is appropriate for being cached or not. Other freebies that we've had added recently is file name parsing, came in about a month ago, I think, which allows you to use the information that's encoded in the path and file name of each of the pieces of your data set. Often people encode useful information there, and you want that to be loaded too. You want that to be part of your data rather than some side code that tries to figure out for each part of your data set where did it come from. Don't be shy. Yes?
So, excuse me. So just to clarify, when intake reads a file, intake is itself reading the file and then passes it to something like pandas. So if pandas could read something but intake can't, then intake wouldn't be able to pass something off to pandas. Is that correct?
Actually, intake is simply calling the same function that you could have called yourself. Intake is handling the prescription of what set of parameters to pass to that function.
Okay. Someone up top? I'm coming.
I didn't see HDF5 as one of the drivers. Is there any work done on that?
There is the Intake Xarray plugin has all of the methods available to Xarray to load netcdf-like things, which includes at least array-oriented HDF5. If you wanted to write an HDF5 tabular reader, that would be very simple to do. Okay. But it doesn't exist yet. The question was, can Intake work with Spark? And as it happens, there is a new repo which has not been released yet, but the code is already in place, at least at a starting level, to enable you to do the same thing for Spark. So in this case, you would encode the set of parameters that you're going to give Spark, but you can put that into a catalog again. So you can use Intake to catalog the set of things that you would like to load using Spark. Now, you probably won't, in that case, want to do a .read to get the whole thing in memory, because the whole point of Spark is to be able to handle much larger data sets than that. You can, it exists, it's a function, but there will also be a toSpark method which will give you the handle to the Spark RDD or data frame, which again is the thing that your end user wants to be able to do their work with. We don't take care of setting up a Spark context for you, so this assumes that you already know how to connect to some Spark cluster somewhere. Okay, it sounds like we've run out of questions, so I will leave it there, and you can find me later to talk about Intake and Dask and Anaconda in general.